If it is of the type greater than or equal to, subtract one surplus variable and add an artificial variable. If we reach positive, then the optimality is reached. If it is negative, then go for one more iteration. This is to be converted into maximization type by multiplying the objective function by -1 by negative sign. Even to convert this 5 by 4 as 0, we are going to use the elementary row operation, that is R1 dash and R2 dash. Hello dear students, welcome to this session of OR class Operation Research. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding how to solve a linear programming problem using Big M method. Now today I will take an example to solve a LPP using Big M method. So this is very important question. It will carry 8 marks. This is an 8 marks question to solve a linear programming problem using Big M method. Big M method, or it is also called as Ogil's method. Now, what is the problem given? Minimum of z is equal to 3x1 plus 2 subjected to the constraints 4x1 plus x2 is equal to 4, 5x1 plus 3x2 is greater than or equal to 7, and 3x1 plus 2x2 is less than or equal to 6, where x1 and x2 is greater than or equal to 0. Since this is a minimization case, this is to be converted into maximization. And the very important concept is, in a constraints, if it is of equal to, for an equal to in constraint, we are going to add an artificial variable. So an artificial variable is to be added, that is A1, an artificial variable. Okay, so if a constraint is of the form equal to, we are going to add an artificial variable A1. So therefore this equation becomes 4x1 plus x2 plus A1 is equal to 4. Right. Now if it is of greater than or equal to sign, then we are going to subtract one surplus variable and add an artificial variable. So here, if the equation is of the form greater than or equal to, we are going to subtract a surplus variable and add an artificial variable. So this equation becomes 5x1 plus 3x2 minus s1 plus a2 is equal to 7. Right. See, if it is of equal to, add an artificial variable. If it is of the type greater than or equal to, subtract one surplus variable and add an artificial variable. Now the third one, if it is of less than or equal to. So here 3x1 plus 2x2 is less than or equal to 6. If the constraint is of the form less than or equal to, add one slack variable s2. A slack variable s2 is added. So therefore this equation becomes 3x1 plus 2x2 plus s2 is equal to 6. Okay. And the very important type is, since the problem is of minimization type, this is to be converted into maximization type by multiplying the objective function by -1 by negative sign. So multiplying the objective function by -1, we will get minimum z becomes maximum of z is equal to minus 3x1 minus x2. So this is nothing but minus 3x1 minus x2. These are the given conditions. Okay, now listen to me. So the first thing is, if the function is of minimization type, then the function is to be converted into maximization type by multiplying the objective function by negative sign. Therefore, the given equation reduces to maximum of z is equal to minus 3x1 minus x2, first condition. Now, the second one is, now the constraints, if the constraints is of the form equal to, then we are going to add an artificial variable a1. So therefore the first equation becomes 4x1 plus x2 plus a1 is equal to 4. Suppose if the equation is of the type greater than or equal to, we are going to subtract one surplus variable and add an artificial variable. So therefore this equation reduces to 5x1 plus 3x2. We are subtracting an surplus variable minus h1 plus adding an artificial variable a2. We are already added a1 in the first equation. So therefore take a2 as the second artificial variable. Whereas if the equation is of the type less than or equal to, then we are going to add a slack variable s2. So therefore this equation reduces to 3x1 plus 2x2 plus s2 is equal to 0. Now therefore the given problem, the given function will reduces to the standard equation. Therefore the standard equation is maximum of z is equal to minus 3x1 minus x2 plus 0 s1 plus 0 s2 minus m into a1 minus m into a2. So slack variable, surplus variable and artificial variable, we have taken minus m because the method itself indicates the big M method. Now subjected to the constraints, what are the constraints? The first constraint is 4x1 plus x2, 4x1 plus x2 plus a1 is equal to 4. And the second equation is 5x1 plus 3x2 minus s1 plus a2 is equal to 7. And the third equation is 3x1 plus 2x2 plus s2 is equal to 6. So this is the actual equation. Okay. Now this equation is to be solved using big M method. Okay. By constructing the initial simplex table. Okay. That's it. This is same as that of the simplex method. Okay. Now before going to the initial simplex table, write down the coefficients. So let me write the coefficients of this. So the coefficients of x1, x2, then s1, s2, a1 and a2 for the constraint. For the coefficients are, so the coefficient of x1 is 4, here it is 1, s1 is 0, s2 is also 0, a1 is 1, a2 is 0. Write down the coefficients of x1, x2, s1, s2, a1, a2 for this constraints. So x1 is 4, x2 is 1, coefficient of s1 is 0, s2 is also 0, a1 is 1 and a2 is 0. For the second equation, the coefficient of x1 is 5, x2 is 3 and s1 is minus 1, s2 is not there, a1 is also not there, a2 is 1. For the third equation, it is 3 and x2 is 2, coefficient of s1 is not there, 0, s2 is 1 and a1 is not there, a2 is also not there. Now if you observe carefully this 1 0 0 0 1 0 0 0 1, this will forms an identity matrix. Okay, this will forms an identity matrix of order 3 rows 3 column 1 0 0 0 1 0 0 0 1. So therefore in the initial basic values we are going to consider a1, a2 and s2 in the first initial simplex table. Okay, a1, a2, s2 and their coefficients. Now what is the coefficient of s2? The coefficient of s2 is 0 and the coefficient of a1 and a2 are minus m and minus m. So I will go to the initial simplex table. Let us construct the initial simplex table with these following conditions. Now come to the first simplex table. So as usual, you know, here it is initial vectors and coefficient of basic variables x0, x1, x2, s1, s2, a1, a2. So in the objective function, the coefficient of x1 is minus 3, minus 2, s1, s2 is 0, 0, a1, a2 is minus m, minus m. So therefore here coefficient of x1 is minus 3, x2 is minus 1, s1 is 0, s2 is 0, initial cost are 0, 0, and coefficient of a1 is minus m and a2 is minus m, the ratios. Now, so here the initial vectors are a1, a2 and s2 because it will form an identity matrix. The coefficient of a1 from the previous is a1 is minus m1, a2 is minus m2 and s1 and s2 are 0. So therefore, coefficient of a1 is minus m, a2 is minus m, s2 is 0, zj and delta j is zj minus cj as usual. Okay. Now, write down the values of x1, x2, s1, s2, a1, a2. The coefficients of x1, x2, s1, s2, a1, a2 from the constraints. So, what are the constraints we have here? So, 4, 1, 0, 5, 3, minus 1, 3, 2 and 0. That I will write the coefficients of x1 is, for the first equation it is 4, 1, s1 is not there, s1 is 0, s2 is also 0, coefficient of a1 is 1 and a2 is 0. Okay, it is 0, right. Next, for the second equation, 5, 3, it is 5, 3 and coefficient s1 is minus 1, then s2 is not there, 0, a1 is 0, a2 is there, 1. Okay. Next, for the third equation it is 3, 2, 0, 1, 3, 2, 0, 1 and a1 and a2 are not there, this is 0 and 0. What are the values of x0? X0 values are 4, 7 and 6. 4, 7 and 6. So, this is how we are going to write the coefficients of x1, x2, s1, s2, a1, a2 from the three constraints. Okay. Now, let us find out the value of delta j. What is delta j? Delta j is nothing but the multiplication of these two. Multiply these two. Minus m into 4 plus minus m into 7 minus m into 7 plus 0 into 6, this is 0, this is equal to minus 4m minus 7m is equal to minus 11m. So, here it is minus 11m. Then, second, these two, multiply these two, minus 4 into m, minus 4m, again minus 5 into m is minus 5m, plus 0 into it is 0, this is equal to minus 9 times m, this is minus 9m. Okay. Now, minus m into 1 is minus m, minus m, minus m into 3 is minus 3m, then 0 into 1 is 0, this is equal to minus 4 times m, this is minus 4m. Okay. Now, minus m into 0 is 0, minus into minus plus m, 0 into this is 0, this is equal to plus m. Here we are going to get it positive m. Again, minus m into 0 is 0, minus m into 0 is 0, 0 into 1 is 0, totally this is 0. Again, minus m into 1 is minus m, minus 1 into 0, m into 0 is 0, 0 into 0 is 0. So, this is equal to minus m again. The last one, m into 0 is 0, minus 1 into m is minus m, plus 0 is minus m. So, zj values we are going to get it as minus 11m, minus 9m, minus 4m, plus m, 0, minus m and minus m. Now, what is this? Delta j minus cj is zj. So, this is here from this I will take from x0, x1 minus 9m minus of minus 3. So, this is equal to minus 9m, minus of minus is plus. So, this can be written as 3 minus 9m. This is 3 minus 9m. Now, let us come to this minus 4m minus of minus 1. This is minus 4m, minus into minus plus 1 minus 4m. This is 1 minus 4m. m minus 0 is m. Again 0 minus 0 is 0. Minus here minus m, minus of minus m. that is minus m, minus into minus plus, that is equal to 0. Similarly, minus m, minus of minus m, this is minus m plus m is equal to 0. Okay, so this is how we are going to get the value of delta j and zj. Zj is equal to, just multiply these elements and add, you will get delta j, and delta j is not zj, and delta j is nothing but zj minus cj. So 9 minus 3m, 11 minus 4m, m 0 0 0. So identify the most negative m values, minus 9m, minus 4m, plus m. So therefore this is the most negative, therefore this is called the incoming variables. This row is called the incoming variable. This is called an incoming column, incoming row. Now it is incoming column. So identify the most negative m value in delta j. This is 3 minus 9m is the most negative. So therefore this is the incoming variable. Now these are the incoming values. Incoming values. Now find out the ratio. What is the ratio now? Ratio is equal to, ratio is x0 divided by x1. As you know, this x0 divided by x1. So x0 divided by x1. So x0, what is x0? 4 divided by x1 is 4. 4 by 4 is equal to 1. Next, x0 is 7 divided by 5. For the second one, it is 7 divided by 5. 7 divided by 5 means divide 5 ones are 5, remaining is 2. 5, that is 20. 5 fours are 1.4. This is 1.4. Next, 6 divided by 3. Third one, 6 divided by 3 is equal to 2. Okay, 1, 1.1 and 2 are the ratios. Now as usual, you identify least positive ratio. This is the least positive ratio. 1 is the least positive ratio. Therefore, this is the outgoing variable. So this is called the outgoing variable. 1 is the least positive. This is the outgoing variable. Now listen to me, I will explain. Find out the value of delta j. Delta j, minus m into 4 is minus 4m, minus 7m is minus 11m, minus m into 4 is minus 4m, minus 5m is minus 9m. Similarly, minus m into 1 is minus m, minus 3m is minus 4m. Again, minus m into 1 is 0, minus m into minus 1 is minus into minus plus m. This is 0, 0 and this is minus m and minus m. Now find out the value of delta j. Delta j is nothing but zj minus cj. Subtract this with these values. Then what you will get? 9. This is as it is. Minus 9m, minus into minus plus. That is nothing but minus 9m plus m, or m3 minus 9m. Similarly, minus 4m minus into minus plus, that is minus 4m plus 1 is 1 minus 4m, and m minus 0 is m. 0 minus 0 is 0, minus m minus into minus is plus, this gets cancelled, we will get it as 0. Identify the most negative m values in this column. So 3 minus 9m is the most negative m values, therefore this is the incoming variables. These are the 4, 5, 7 or the 4, 5, 3 are the incoming variables. Now find out the ratio. As we know, the formula for ratio is, here it is x0 and incoming value is x1. So x0 by x1 ratio will gives the ratio. So therefore x0 by x1 is equal to 4 by 4 is 1, and 7 by 5 is equal to 1.2, and 6 by 3 is equal to 2. Identify the least positive value in the ratio column. So here 1 is the least positive, therefore this is the outgoing variable. So that means a1 is outgoing, whereas incoming is nothing but x1. So a1 is replaced by x1 in the next column. See, if all the values are positive, then we can say optimality is reached, but here optimality is not reached. We will go for the first iteration. So this is the incoming variable and outgoing variable. That means the incoming variables are x1 and outgoing variables are a1. So in the next iteration, next simplex table, this a1 is replaced by x1. So a1 is replaced by x1 and a2, s2 are as it is, and the coefficient of x1 is minus. So this becomes minus 3, minus m and 0. Okay. And the very important step is convert the key element. What is the key element here? The intersection of the key row and key column is 4. This element is to be converted. Convert this 4 as 1. So for converting this 4 as 1, we are going to divide this entire row by 4. Divide this entire row by 4 so that 4 by 4, 4 by 4, 1 by 4, 0, 0, 1 by 4 and 0. This becomes 1, 1, 1 by 4, 0, 0, 1 by 4 and 0. Now, I'll write, so new row dash, R1 dash is equal to R1 divided by 4. What is R1? R1 contains 4, 4, 4, 4, 1, 0, 0, 0, 0, again 1, 0, 1, 0. Divide entire row by 4. So, if you divide by 4, you are going to get a new row, that is R1 dash. 4 by 4 is 1, again 4 by 4 is 1, 1 by 4, 0, 0, 1 by 4 and 0. This is the new row 1, R1 dash in the first iteration table. I will write here. So, this is 1, 1, 1 by 4, 1, 1, 1 by 4, 0, 0, 1 by 4, again it is 0. Okay, this is R1 dash. Now, the second step is convert all the elements below this, that is all the elements below this 5 and 3 as zeros. So, to convert this as 5 and 3 as zeros, we are going to use the proper elementary row operation. So, using elementary row operation, we can convert this 5 as 0 and 3 as 0. So, to convert this, we are going to use R2 dash is equal to R2 minus 5 times R1. Okay, listen, write down the R2. What is R2? Here, R2 is nothing but the old elements, all the elements of row 2 from the first table. 7, 5, 3, we have 7, 5, 3, then minus 1, 0, 0, 1, minus 1, 0, 0, 1. Let me check. 7, 5, 3, 7, 5, 3, then minus 1, 0, 0, minus 1, 0, 0 and 1. Now, this new elements, consider these new elements, that is 1, 1, 1 by 4, 0, 0, 1 by 4 and 0. Now, just multiply this with 5, 5 R1. Just multiply this with 5, what you are going to get it as? This is 5, 5, 5 by 4, 0, 0, 5 by 4 and 0. Now, subtract these two. 7 minus 5, I will write the steps for your convenience. 7 minus 5, this is 5 minus 5. Again, 3 minus 5 by 4. Then minus 1 minus 0. Again, 0 minus 0, 0 minus 1 by 4 and 1 minus 0. So, this is 7 minus 5 is 2, 5 minus 5 is 0. Take LCM, 4 is the LCM, 4 3 is 12 minus 5. 12 minus 5 is nothing but 7 by 4. Then this is minus 1 minus 0 is minus 1, 0 minus 1 by 4 and 1. So, these are the values of R2 dash. Substitute here. So, what are values of R2 dash? So, that is 207, 2, 0, 7 by 4, minus 1, 0, minus 1 by 4 and 1. These are the values of R2 dash. See here. So, the element below 1 is 0. Now, again this is also equal to 0. Convert this element as 0. So, to convert this element as 0, again we are going to use the elementary row operation. R3 dash is equal to R3 minus 3R1. So, again we are going to use R3 dash is equal to, now R3 dash is equal to R3 minus 3R1. So, what are the elements of R3? The old elements 6, 3, 2. I will write here elements of R3. What are the elements of R3? 6, 3, 2, 6, 3, 2, then 6, 3, 2, 0 1 0 0. 0 1 0 0. Now R3 minus 3 times R1. So for this multiply by 3. Multiply by 3 times R1. If you multiply by 3, what you will get? So this is 6 in 3 into 1 is 3. 3 into 1 is 3. Again 3 into 1 by 4 is 3 by 4. 0 0 3 by 4 and 0. Now subtract this. So this is 3R1. 6 minus 3 is 3. 3 minus 3 is 0. 2 minus 3 by 4. 0 1. 0 minus 3 by 4 and 0. This is equal to 3 0. 4 2s are 8 minus 3. 5 by 4 8 comma 0 1 minus 3 by 4 and 0. I'll write here. So 3 0. This is 3 0. Then 5 by 4. 5 by 4. Yes, 5 by 4. 0 1 0 1 minus 3 by 4 and 0. So these are the values. See, so in the first iteration simplex table, the key element is 1 and the elements below the key element must be zeros. Okay. Now as usual, find out Zj and Cj. Verify whether all the values of Zj minus Cj are positive and the whether of the optimality is reached or not. If it is not, go for the next iteration. Okay. Now let us find out the values of this Zj. Zj is equal to minus 3 into 1 is minus 3. I'll go to the next page. Yes. Minus 3 into 1 plus minus m into 2. This is Zj and plus 0 into 3 is 0 plus 0. This is equal to minus 3 minus 2m. Okay. So this becomes minus 3 minus 2m. Minus 3 minus 2m. Again minus 1 into 3 is minus 3 plus 0 0 it is minus 3. Minus 3 into 1 by 4. Minus 3 into 1 by 4 plus minus m into 7 by 4 into m minus 7 by 4m. Then 0 into this is 0. So this is take LCM, 4 is the LCM, minus 3 minus 7m. So this is minus 3 minus 7m by 4. Minus 3 minus 7m divided by 4. Okay. Next. Again this one. Minus 3 into 0 is 0. Minus into minus plus m. This is plus m. Again 0 plus 0 plus 0. This is 0. Again minus 3 by 4. Minus 3 by 4 plus minus m into 5 by 4. Minus m into minus 5 by 4 plus 0. That is take LCM. 4 is the LCM. Minus 3 minus into minus plus 5m by 4. So that is nothing but 5m minus 3 by 4. 5m minus 3 divided by 4. And this is minus m. These are the values of Zj. Now find out delta j. Delta j is nothing but Zj minus Cj. Now this is minus 3 minus 3 minus 3 delta j. Minus 3 minus of minus 3 minus 3 plus 3, this is equal to 0. Now if you subtract minus 3 minus 7m by 4 minus 1, take LCM, 4 is LCM, minus 3 minus 7m minus 4. This is minus 7 minus 7m by 4. So this becomes minus 7 minus 7m divided by 4. Now m minus 0 is m. 0 minus 0 is 0. Again this minus of minus m, that is 5m minus 3 by 4 minus of minus it is plus, that is 4 is LCM, 5m minus 3 plus 4m. This is nothing but 9m minus 3 by 4. 9m minus 3 by 4. Minus into minus becomes plus, this is 0. Since here minus 3 minus 7m by 4, minus of minus becomes plus, this is plus 4. So what we will get here, minus 4 minus 3 is minus 1. So this is minus 1 minus 7m by 4. This is minus 1, not this is minus 1. Minus 1 minus 7m by 4. Okay, right. Now identify the most negative m value. Here we have, this is the most negative m value. Therefore, this is the incoming variable. Again, incoming variable. So here x2 is the incoming variables. Now just find out the key value. This is the key row. Okay. Now find out the ratios. That's all. Now the ratios are here. This is x2. Ratios are x0 divided by ratios. x0 divided by x2. Now what are x0 by x2? x0 1 divided by 1 by 4. 1 divided by 1 by 4, this is equal to 4. The second one, 2 divided by 7 by 4. 2 divided by 7 by 4 means 2 into 4 by 7, this is 8 by 7. 8 by 7 means approximately how much we will get? 1.14. Next, 3 divided by 5 by 4. 3 divided by 5 by 4, that is nothing but 3 into 4 by 5. 3 4s are 12 by 5. 12 by 5 means 5 2s are 10. 2.4. 2.4. Now what are the ratios? 4, 1.14 and 2.4. Now identify the least positive. What is the least positive value here? This is the least positive, 1.14. So therefore this is called the outgoing variable. This is outgoing variable. So incoming is x2, outgoing variable. What is outgoing variable? A2. So A2 is the outgoing variable. Since here the optimality is not reached, we have to go for one more iteration, that is iteration 2. In the next iteration, what are the steps? So convert this 7 by 4 as 1 and 1 by 4 and 5 by 4 as 1 and 1 using the elementary row operation. And again here, since A2 is the outgoing variable, this A2 is replaced by x2. The coefficient of x2 is minus 1. This is minus 3, minus 1 and 0. So I will go to the next table, iteration number 2. So in the second iteration, we will have the initial vectors x1, x2, s2 and delta j, zj minus cj. And the coefficients of the basic variable, x1 is minus 3, x2 is minus 1 and s2 is equal to 0. Okay. Now here if you want, you can remove this a1 and a2. Okay, because already a1 and a2 are the outgoing variables. So what is left over? You can perform the operation up to this, that is enough. Now verify all the values up to this are negative or positive. If you reach positive, then the optimality is reached. If it is negative, then go for one more iteration. Now first, what is the first step you want to do is convert this 7 by 4 as 1. So R2 dash is equal to R2 divided by 7 by 4. Now R2 dash is equal to R2 divided by 7 by 4. Now what are the elements of R2? I will write the R2, 2, 0, 7 by 4, 2, 0, 7 by 4, 2, 0, 7 by 5, minus 1, 0, minus 5 by 4, minus 1, 0, minus 5 by 4 and 1. Now divide by 7 by 4. Now what is this equal to? So this is 2 into 4 by 7, 8 by 7. This is 0. This is 1. Again minus 4 by 7. Then this is 0. Again minus 5 by 4 into 4 by 7, 4 and 4 gets cancelled. We will get minus 7 by 4. 1 divided by, this is 4 by 7. Okay. I'll write down the elements of R2 dash. R2 dash is equal to 8 by 7, 0. First it is 8 by 7, 0. Then 1 minus 4 by 7. 1 minus 4 by 7. Again 0 minus 5 by 7. 0 minus 5 by 7. And last element is 4 by 7. Okay. Now the next step is convert this 1 by 4 as 0. So for this converting 1 by 4 as 0, we are going to use the elementary row operation as like previous case. Even to convert this 5 by 4 as 0, we are going to use the elementary row operation, that is R1 dash and the R2 dash. Okay. Now R1 dash is equal to R1 minus 1 by 4 R2 times. So R1 dash is equal to R1 minus 1 by 4 R2 dash. So if we use the elementary row operation and subtract, what are the elements we are going to get? 5 by 7, 1, and this reduces to 0. Then this is 1 by 7, 0, 3 by 7 and 1 by 7. Okay. Now, so to convert R3 dash, we are going to use R3 dash is equal to R3 minus 5 by 4 times R1. So if you use this operation, see here, R3 minus 5 by 4 R1, this reduces to 0 and these elements will reduce us to 11 by 7, 0, this is also 0. Okay. So then this becomes 5 by 7, 1, this is 1 by 7 and this is minus 5 by 7. Okay, these are the values we are going to get by using the elementary row operation. So that is for R3 dash we are using R3 minus 5 by 4 R1. These are the elements we are going to get. Now similarly find out the value of delta J, Zj. Zj is equal to, this is minus 3 into 5 by 7 minus 1 into 8 by 7. Take LCM, 7 is LCM, minus 15 minus 8. This is minus 23 by 7. So you will get here minus 23 by 7. This is minus 3. Again this is minus 1. Again minus 3 by 7. Minus 3 by 7. Minus into minus plus 4 by 7. This is 7 is LCM. This is 1 by 7 again. 0 and this is 0. Again minus 3 by 7. Minus 3 3s are 9 by 7. Again minus into minus plus 5 by 7. This is nothing but minus 4 by 7. And the last is minus 3 by 7. Minus 3 by 7. Minus 4 by 7. And 0, this is minus 7 by 7, that's equal to minus 1. Now, this is minus 3, 0, minus 1 plus 0. This is positive 1 by 7, 0, and this is, if you want you can do, otherwise you can stop here itself, minus 4, minus 7, minus into minus, plus m, minus 1, minus into minus. So, there is no least negative m value. Since m values are positive, since you can eliminate a1 and a2 because a1 and a2 are the outgoing variables. If you check up to this, see here, all the elements in delta J column are positive, greater than or equal to 0. So therefore the optimality is reached. Optimality is reached. The optimality is reached, and the maximum, the value is, here it is minus 23 by 7, where x1 is equal to 5 by 7 and x2 is equal to 8 by 7. So therefore I will write here, therefore the values of x1, therefore x1 is equal to 5 by 7, and x2 is equal to, x1 is 5 by 7, x2 is equal to 8 by 7. What is required to find? Is to find the maximum value. Maximum is minus 3x1 minus x2. So therefore, max z is equal to minus 3x1 minus x2. Substitute here, minus 3 into 5 by 7 minus 8 by 7. 7 is the LCM, minus 15 minus 8 is minus 23 divided by 7. Max z is equal to minus 23 by 7. Since what is required to find is the minimum value, therefore for this multiply by negative side. Therefore the minimum of z is equal to minus of minus 23 by 7 is plus 23 by 7. This is the required answer. Minimum. So therefore the minimum of z is equal to, minimum of z is equal to 23 by 7. This is the required answer. So the required answer is 23 by 7. This is how we are going to find the minimum and maximum value of a given linear programming problem using big M method. Okay. Therefore, minimum of z is equal to 23 by 7 at x1 is equal to, what is the value of x1? 5 by 7, and x2 is equal to 8 by 7. So this is the required answer. This is how we are going to find the minimum and maximum value of a linear programming problem using big M method. Hope you followed. That's all for today's session. Let us meet with a different problem in different class. Thank you.